Lesson 13, calculating and comparing square roots. A perfect square is just a number that is the square of an integer. So when you square an integer, the number you get is called a perfect square. So a perfect square is a number that is the square of an integer. So here's some examples of perfect squares. So if I take the integer 0 and square it, 0 squared is 0. And then the next integer, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and so on. It's called a perfect square because if you were to have a square with 2 units on one side, the area would be 2 times 2 or 4, which is a perfect square. Now if we had a square with 3 on a side, to find the area, we would do 3 times 3, which is 9. So that's just the area of a square. Those numbers are perfect squares. When we take the square root of a number, the square root symbol is called the radical symbol. The number inside is called the radicand. So let me give some examples. The square root of 50. The radicand is 50. The square root of x is the number whose square is x. So whatever number that you use to square and get x, that number is the square root of x. The square root of 25. We want the number whose square is 25. So the number that we square to get 25 is 5. Is the radicand, here's a question, is the radicand and the square root of 15 a perfect square? That means, can we find an integer that when we square it, we get 15? And the answer is no. Sometimes we'll get questions like this. What two consecutive integers is the square root of 50 between? What I like to do is I like to find the perfect squares that's just less than 50 and the one that comes after 50. So we could say that the square root of 49, 49 is a perfect square, is less than the square root of 50, which is less than the next perfect square, which is 64. So when you take the square root of 49, you get 7. And when you take the square root of 64, you get 8. So the square root of 50 is between 7 and 8. Estimate, here's another example. Estimate the square root of 23 to the nearest integer. So I like to find the perfect squares that are before it, the one before it, and the one above it. So if we look at a number line, the square root of 16 is less than the square root of 23, and the next square root is the square root of 25. So this is 4, square root of 16 is 4, square root of 25 is 5. The square root of 23 is closer to the square root of 25 than it is the square root of 16. So the square root of 23 fits about right here. So we can say that the square root of 23 is closest to the number 5. And that's the end of the lesson.